What's up, Algebra 2 students? We're going to talk about more solving quadratics in this unit, Unit 6. More solving like equations with x squared plus some stuff typically equal to 0. But we're going to shift our focus from like factoring, which is what we were doing, to like undoing the square using a square root. Now, like, do we know what a square root is? Well, like, a lot of times when we were factoring, say we had like x squared minus 81, okay? We said you got to figure out what is the term that's multiplied by itself to get x squared and what's the thing multiplied by itself to get 81. And a lot of people were given like little cheat sheets kind of thing where it's like, hey, 2 squared is 4, 3 squared is 9. And to figure out what like is the second term, because we realize this is a difference of squares, we got x plus something and x minus something. To figure out what goes here, you had to like keep guessing and figure out like what is the number that's squared that gets 81. Many of you just know this right off the bat. I'm just doing this to just show you. Like this would be the process of figuring that out. And you like keep going and you're like, oh, I don't know. And then you go and you finally it's like, oh, there, 9. 9 squares, 81. Well, did you know that the square root tells you what number times itself gets 81? Square root, which is second and above x squared, if you use a graphing calculator, if you use one of these TI-30XSs, is the same thing. It's above the x squared. You have to press second, and then the square root shows up. Okay? We could have typed in the square root of 81 and had the calculator just give us that number, not doing any guessing and checking. So we would have figured out, oh, the square root of 81 is just 9. And so like other numbers that could have showed up, like 36. If I want to know what number times itself is 36, I would take the square root of 36. And I get the number times itself. The square root of 36 is 6. And that just means like 6 squared equals 36. This just means 9 squared equals 81. So it's a way to kind of undo the squaring. Okay, we're undoing squaring. But now we get to this square root of 45. Okay, and if I type in the square root of 45, I realize it's not a nice number. It'd be nice if I could just like, use my decimal. But for the purposes of getting a simple answer and to be able to think like back in the day before we were able to use calculators, like what is the square root of 5 really? And to calculate it exactly, mathematicians used to have to simplify this stuff. Simplify square root of 45 so that we have like an amount of easier square roots, okay? And what we're going to do is we're going to use the idea that square roots can be written as the square root of two numbers. Like, let's say I have the square root of 32. The square root of 32 is actually the exact same as the square root of 16 times the square root of 2. It's like 16 times 2 gives us 32. Okay, so watch this. The square root of 32 is this number. Watch, I can do the square root of 16 times the square root of 2, and I'm going to get that exact same number. Okay? But the great thing about what I just did, write it as 16 times 2, is because the square root of 16 is just a nice number, 4. And actually 4 times the square root of 2, this was something that mathematicians could do by hand a lot easier before calculators. And it'll actually help us simplify and create really nice looking answers when we're solving these quadratics in this unit. And I can see I get that same number, okay? So our goal here is to simplify root 45 into some amount of easier square roots, okay? And what we're going to do is we're going to focus on our perfect squares. All these numbers are our perfect squares, like 25, 36, 49, 64, 81, 100. And all we're going to do is try to figure out like, hey, what perfect square can be divided into 45? Okay, so I'm going to start with like a number that I think can divide in there, and I get 30, and I'm trying 36. Now I know 36 isn't going to go into 45 because 36 is like bigger than half of 45. Some of your students asked if you were coming in. I said like maybe, maybe not, but if it's not, you're still taking the test, and if it is, like then you're fine. You know what I mean? So I said like, yeah. Anyways, do you need anything?
No, I just need to charge.
Cool. So I get 45 divided by 36, and it's like, no, that doesn't work. Is that a whole number answer, 1.25? No, no. So it doesn't divide evenly, so I'm just going to keep going. The next perfect square is 25, so I'm going to try to divide it by 25. Doesn't work. It gets 1.8. Is that a whole number? No. So then I'm going to go and try the next one. 16. So 45 divided by 16. Hoping that works.
I saw your picture. I had a quick question to you.
And it doesn't.
No, I'm sorry.
What is it like a carpet?
Yeah.
I'll be back. I'll be down in my room in like 15 minutes.
And then we try 9. 9, finally, is a perfect square that fits nicely into 45. Why do we want to do that? Because we can write the square root of 45 as the square root of 9 times the square root of 5. Watch, the square root of 45 turns out is this decimal. We know it's between 6 and 7, but it's 6.708. If I wrote the square root of 9 times the square root of 5, I get 6.708. But what's more important is that the square root of 9 is 3. Like the square root of 9 is 3. The square root of 5 is not a perfect number. So like I'm just going to leave my answer as the 3 square root of 5. That's the key to this lesson. And it's going to help us when we start solving using squaring roots, understanding how to simplify these roots. Okay? So all we're going to do is we're going to start with our number inside our square root. So 8. We are going to divide out the biggest perfect square. Now, like, what are the perfect squares? Again, along this diagonal, 1, 4, 9, 16, 25. I can take the square root of all these numbers, and I get a whole number. I can't take the square root of 8. It's bad. But I know that 8 can be divided by 4, 4 being a perfect square. And it's 4 times 2. That means I can write root 4 times root 2. Root 4 times root 2. And I get that same number, square root of 8. Okay, so I'm going to write this as root 4 root 2. And then I realize, oh, okay, I know what the square root of 4 is. It's 2. I still don't know what the square root of 2 is. So I'm going to leave that. But if I combine 2 and square root 2, I get that 2.82 number. And this is what we call a simplified radical. Simplified radical 8. Okay? And that's what we're going to continue to do. Just divide by big perfect squares. So what are the list of squares? I'm gonna kind of move this down here. We're paying attention. I'm gonna go big to small. Like 100, there's bigger numbers than that, of course. 81 is 9 squared. 8 squared is 64. 7 squared is 49. 36, 25, 16. It's 4 squared, 9, 4. Okay? So 12, let's see. I could try to divide that by 9. You know that 12 can't be divided by 9, but whatever. So it doesn't work. But then I try 4. It's great. Okay, 4 times 3 is 12. Now, root 4 times root 3 is 12. You don't say like 4 times 3 is root 12. It's like root 12 is 3.464. Root 4 times root 3 is 3.464. The square root of 4 is 2. Like this is a perfect square. The square root of 4 is 2. 2 times root 3 is 3.464. I'm not changing what I have. I'm just simplifying it, making it something that actually is a lot easier to figure out perfectly using without using a calculator, which is what mathematicians had to do, which is why we have to do this. Calculators now kind of like defeat the purpose of like simplifying, but it's just something that's become like standard in mathematics is to simplify answers in case we didn't have a calculator. Okay, now let's try 17. So the square root of 17, I'm going to try to rewrite that as something. So I'm going to start without the square root, just with 17, and divide that by 9. Nope. Try to divide that by 4. Nope. So guess what? This is simplified. You can't do anything. Maybe you put a 1 next to it. So 1 root 17. Can't do anything. Let's try 20. 20 divided by 16, you know that's not going to work. So maybe instead you try 20 divided by 9. Sorry. Doesn't work. 20 divided by 4. Does work. Okay? 4 times 5. Now make sure we understand this. It's not 4 times 5. It's root 4 times root 5 is the same as root 20. Okay? Roots work as like exponents, so this is why we're able to split this up and it works. If you don't care about that, that's fine. Okay? Now, 2 is the square root of 4. 2 root 5 is the same as root 4 root 5 is the same as root 20. We have simplified fully. Okay? 24. Try 16. Try 9. Try 4. There it is. Root 4 root 6. You can type that into your calculator. The square root of 4 is 2. The square root of 6 cannot be done. I could take the square root of 4, get a whole number. I can't take the square root of 6. Okay, there's no whole number times itself that gives us 6, so I've just simplified. Okay, now it's not always going to be 4. All of these were 4, but like 50, like, I don't know, start with 36. Doesn't work. Go to 25. Oh, yeah. Okay, root 50 is the same as root 25 times root 2. Okay, so root 25, root 2. The square root of 25 is going to be a perfect number. We're undoing the square. 5 squared is 25. The square root of 25 is 5. The square root of 2 is the square root of 2. It's a decimal. So I leave this as 5 times the square root of 2. Okay, let's try 46. Try 16, I try 9. I'm not trying 25 because 25 times 2 is 50, so I know it's got to be smaller than that. Try 4. Doesn't work. None of these perfect squares fit nicely into 46, so we say this is simplified. We can't do anything. Okay, let's look at root 75. Again, I'm guessing 25 works, but we should check, like check 49. Check 36, check 25, and poof. Root 25, root 3. Make sure like that makes sense to you. Root 75 is root 25 times root 3. 5 is the square root of 25. The square root of 3 is not a whole number. So the square root of 25, 5 times root 3 is the square root of 75. Okay. 80 is a big number. Let's try 36. Nope. Let's try 25. Nope. Let's try 16. Ooh, actually surprised by that. I was thinking we have to go down to 4. But this is how you got to do it. Because if you started with 4, you would have gotten like a 20, and you could pull out another 4 out of that. So anyways, root 16, root 5. The square root of 5 is a decimal. The square root of 16 is 4. This is your simplified root 80. They're the same. Okay? Just going to do this because I know 25 and 5 make 125. 5 root 5. Root 125 is 5 times the square root of 5. Okay. Sometimes you already have a number outside of things. So like 3 root 4. Well, root 4 is 2, so actually 3 root 4 is the same as 6. Like you might start with 3 root 4, but you need to figure out, oh, well, I know the square root of 4 is just 2. So 3 times 2 is the same as 3 root 4. Now, that's not really like a classical example. A classical example would be like 5 root 48, where like root 48 is not a whole number. Okay, it's that. Okay, so this is when we have to start dividing and try to simplify 48, root 48. And I get 16 goes into 48 3 times. So watch what I'm going to do. I have 5, and I'm going to rewrite root 48 as root 16, root, how many times is it going? 3. Okay, now this is times, okay? Watch, 5 times 4 times root 3. 5 times 4 times root 3 is the same as 5 root 48. But guess what? I know what 5 times 4 is, so I can multiply those together to get 20 root 3s. Okay? So like we're not going to panic. We're just going to either figure out what it is, and then we know what it is. 2 root 9 is just 6. Do you need to talk or?
No.
right.
Sorry.
And then here, this is just 20. But it's more like situations like this when we need to simplify the root and then combine like the numbers and leave the root that can't be simplified. So I'm going to focus on the root 18. Root 18, I know it's not going to be 16, so it's got to be 9, yep. So root 18 is root 9 times root 2. So I got 2 times root 9 times root 2. The square root of 9 is 3. Look, you type in the square root of 9. You get 3. So you don't put root 3. It's like the square root of 9 is 3. The square root of 2 is a decimal. So you don't replace the square root of 2 with anything because it's an ugly number. But you got 2 times 3 times root 2. 2 times 3 can be simplified to be 6. 6 root 2. Let me just show you. 2 root 18 is the same as 6 root 2. Okay? I'm going to kind of blow through the other ones and get to the next part. Root 27 is root 9 root 3. 9 is the biggest number that goes in there. The square root of 9, type it into your calculator, is 3. 3 times root 3 is 9 root 3. I can check. Type this into your calculator, type this into your calculator, you get the same value. 50 is 25 and 2. 25, the biggest perfect square. Root 25 is 5. Just 5, not the square root of 5. Root 2 is just root 2. It's an ugly decimal, so leave it as root 2. But 6 times 5 is 30. 30 times root 2 is the exact same as 60 times root 50. Ooh, I don't know about 128, so I need some help here. I'm going to use Mr. Calculator. 64 is a good number to start with. Start with the biggest number possible. So biggest numbers are 81, 64, 49, 25, 36. So I'm going to start with 64, and I realized, yep, 64 times 2. So now be careful. 64, 2. you can take the square root of 64. This is the whole like undoing a square. 8 squared is 64. So this is 2 times 8 times root 2. 2 times 8 is 16. 16 root 2. Plug that into your calculator. It's the exact same thing as plugging 2 root 128 into your calculator. Okay? All right, now we can have fractions with this. Square roots kind of work like exponents. So 2/3 squared. If I ask you, what's 2/3 squared? Sure, you could type it into your calculator. But you know squaring is just like something times itself, which means like, oh, 2 times 2, that's 4. 3 times 3, that's 9. Oh, I just like square the top and square the bottom. Like you just square the 2 and you square the 3 separately. Okay, so because square roots just work like that, if you want to take the square root of 4/9, you actually can take the square root of 4 and then the square root of 9 separately and realize that the square root of 4 is just 2, the square root of 9 is just 3, and you get 2/3. So if you have a fraction inside a square root, which is kind of like a product, you can write it as the square root of the top and the square root of the bottom. Use your calculator. Square root of 25 is just 5. The square root of 16 is just 4. This is an easier number to work with instead of using square roots. Square root of 1, square root of 49. Now, we haven't talked about the square root of 1, but 1 is a perfect square, which means you can take the square root of 1. It's just 1. You can take the square root of 49. Maybe you're not sure. You just check. And if it's not a perfect number, if it's not a whole number, you start dividing it by perfect squares. You work with that, okay? You realize it's like, this is not that bad. Until we get something like this. Okay, the square root of 25 is 5, but what's the square root of 8? Well, I can't take the square root of 8, Mr. Messner. It's not a whole number. This is where we try to simplify. Oh, 8 is 4 times 2. This is root 4 times root 2. 8, root 8 is root 4 times root 2. Okay, but root 4 is 2. And this would be the right answer. Double checking, the square root of 8 over 25 is the same as 2 times the square root of 2 divided by 5. Okay, now in this unit we're going to be using a formula. The formula has a square root of b squared minus 4ac. We're going to show you where this formula comes from. It's called the quadratic formula. It's going to help us solve any quadratic equation. Okay. Now, what's important is that we have like a big set of parentheses inside this square root. You might be thinking, oh, we've been doing something where I can just split this off and say root 4 times root 10. But that's going to not work for things over addition. See this like addition and the subtraction? It's kind of like if I ask you x plus 4, what's x plus 4 squared? Or let's say 3 plus 4 squared. Let's get rid of x. You'd probably think, oh, that's 7 squared, that's 49, and you're correct. But what if you tried to simplify this first and say, oh, isn't this like 3 squared plus 4 squared? Well, like this is 9 plus 16. 9 plus 16 is 25. Those aren't the same, which means you actually can't do this, okay? So you see this formula? A lot of you are going to want to square root this b squared and then square root the 4ac. You can't do that, okay? I'll just show you, like, think of this as a big set of parentheses. The subtraction prevents us from being able to square root the left and the right side, kind of like what we're doing here. So here's an example of like what we can't do with square roots. if I ask you, what's the square root of 9 plus 16? Many of you might be saying, oh, it's the square root of 9 plus the square root of 16. And you might be thinking it's 3 plus 4, which is 7. But let's look at our calculator. What's our calculator? You guys don't usually believe your teachers, but you leave your calculator. The square root of 9 plus 16. Oh, we think it's going to be 7. It's not. It's just 5. Okay? We have to simplify the stuff with the addition in the parentheses first before we take the square root. So that was a lot just to say, yo, just be careful here. Don't separate the square roots like we've been doing. Instead, this is what we're going to do. We are going to practice plugging in values into this formula. Okay? And then we're just going to simplify. So like if A is 1, B is 5, and C is 6, plug these in here. The key is just to like use parentheses, especially when you're squaring. Okay? And I'm going to write this out just for fun, but you guys will be able to do the following. Figure out what this stuff inside this b squared minus 4ac, what is that inside the square root? Work on that first. Sorry, use parentheses. 5 squared minus 4 times 1 times 6. You get the square root of 1. You try to figure out, is that a whole number? It is. We're done. You get 1. Okay, let's look at this one. The square root of 4 squared minus 4 times 1 times negative 5. All right, I'm going to work on the inside first. I'm not going to try to distribute the square root or anything. I'm just going to say what's 4 squared minus 4 times, I didn't need parentheses around that 4, but it's fine, 1 times negative 5. 36. Next step, can you take the square root of 36? Yes, it's just going to be 6. Okay, this is what we're doing. Be careful when b is negative. If b is negative, make sure you have this around parentheses because negative 8 squared should give you a positive 64. Watch. If you plug in negative 8 squared without parentheses, your calculator deceives you. Your calculator says, oh, I know what 8 squared is. It's 64, and then I'm going to make it negative. But you know that negative 8 squared, negative 8 times negative 8 is positive 64. So again, just use parentheses, and you'll be okay. Get the square root of 16. Can you take the square root of 16? Yes. You get 4. Okay. B is negative squared minus 4 times A times C. 64. The square root of 64 you can find. Okay. We will have situations where it's not going to be perfect numbers. These last 4 are like that. So, b squared minus 4 times a times c. $56. Okay. Can you take the square root of 56? No. It's a decimal. Can you simplify this? Let's try. Divide it by 36. Nope. Divide it by 25. No, because it's 2550. Divide it by 16. Close. Divide it by 9. Close. Divide it by 4. Ooh, look at that. Root 4 root 14 is root 56. You cannot take the square root of 14. It's a decimal. You can't divide any more numbers out of 14. But you can take the square root of 4. The square root of 4 is 2. 2 root 14 is the same as b squared minus 4ac square rooted at the beginning. I don't know why I kept writing 16. This is a 14. Okay? Let's do it here. B squared minus 4 times A times C. 88. Cool. I think this is another deal with 4. 49 is not going to work. 25 is not going to work. 36. 16. 4. 9. 9 doesn't work, but 4. Root 4, root 22. Root 4 is 2. Root 22 cannot be simplified. What about this? B squared minus 4 times 1 times negative 9. Root 72. I know what that is. That's root 9, root 8. Ooh, hold on. 36. Way to go. Who came up with this problem? That's a good one. 36 root 2. Let's say you just pick 9. You'd have 9 times 8. 8 you can do 4 times 2, which is 2 root 2. So you would not have gotten the largest perfect square. Start with big numbers. Start with the biggest numbers. 6 root 2. Ooh, look at this. A is negative 63. Why did I do this? B squared minus 4 times negative 63 times 1/2. 162. I think I gave this for a reason. Okay, start dividing. Well, 100 doesn't work. Let's try 81. Ooh, root 81, root 2. Start with the big numbers, and then you'll be able to simplify it easily. The square root of 81 is a nice number, 9 root 2. Okay? That's it for simplifying square roots. We will be simplifying lots of square roots in this unit, so we're ready to do that now. Next class, we will be solving equations using square roots. So we're ready to simplify our answers when we start to solve. Thanks.